Okay. Hi, everybody. Welcome. Good morning, good afternoon, hello, depending on where you are. Um, my name is Michael Fitzsimons. Welcome to the May Gen 3 Community Forum. Uh, Today's community forum, or this month's community forum, is going to be a little different than our typical community forums. Usually we're bringing different Gen 3 operators together for knowledge sharing or discussing some new feature capability. But today, based on request, we're going to have a broad overview of Gen 3. So this is intended to help new or potential Gen 3 users. Maybe also hopefully to help experienced Gen 3 users. They may learn something they didn't know about Gen 3. But primarily it'll be a resource for people that want to yeah, learn basically about what Gen 3 can offer and a little bit about how to run it and how to operate it. It is not going to be it's going to be broad. We won't get into too much detail on any particular topic because there's a lot to discuss. So if you have questions, feel free to ask them in the chat or reach out after the fact about particular topics that you might want to learn more about. The other thing I'll just mention before we get started is that this is really going to be about kind of current Gen 3 capabilities. We did have a separate roadmap meeting in January, and you can find that on the gen3.org page if you have questions about sort of what's coming in Gen 3. But this is meant to cover a majority of the basic capabilities from Gen 3. So with that, I will get started. Next slide, please. So what is the agenda for today? I'm going to kick off with talking about what is Gen 3 and what problems is it trying to solve. Then give a really high-level overview of Gen 3 products and features. Then I'll turn it over to my colleague Chris Meyer, who's the Director of User and Data Services, to talk about how to use a Gen 3 system. Then Alex Van Tol, our Chief Architect for Gen 3, will talk about creating and maintaining a Gen 3 system. And then finally, I'll wrap it up again with some instructions or guidance on how you can contribute to Gen 3 and to the community. Next slide. So why use Gen 3? What is Gen 3 trying to solve? I think the fundamental issue is that sharing research data can be hard um, for a couple of reasons. I've listed a few here. Uh, there's often very low incentive to share your data. Um, Sponsor requirements are beginning to change this, but generally, once data serve their initial purpose, there's a lack of effort to open the data up to competitors or colleagues. Um, because of this, there's often the quality of the data or the metadata is often low. So perhaps the data are shared, but they're not well described, and so it can be difficult for anybody to sort of properly make use of the new data. Also, data are shared in a variety of systems, and so there may be system architecture incompatibility, meaning basically that it can be hard to get the data out of there. There might not be an API, or it may not use standard protocols for pulling data, et cetera. So there's a number of reasons why, uh, even though, we spend a lot of money and resources to create these beautiful data sets, sometimes they're not easy to share or find with the community. Next slide. So what is a Gen 3 approach? Basically, data commons provide a secure platform for integrated data management and analysis, open to the entire scientific research community. And we leave it up to the operator to decide how public the system and data are. So you can configure it such that everything's completely open access and everybody can access your platform, or it can be very locked down and all the data are also locked down. Gen 3 is open source, so it's open to the public to modify or extend. This promotes study reproducibility and accelerates novel discoveries. Um, Also, we use standardized software services, which promotes interoperation and the emergence of data meshes, which I'll tell you more about later. This figure is just trying to diagram how different groups, developers, data analysts can all access data within a data commons. Next slide, please. Why use Gen 3? What is fair? So Gen 3 is designed to make it easy for research communities to create fair data commons at minimal cost and technical barrier. Um, we know that data commons serve a need and they make data available. And the goal here with having open source Gen 3 is to make this easy for groups to create their own system with, as I said, with minimal costs and technical barrier. Uh, we try to abide by the FAIR principles. So what is FAIR if you've not heard of this? This is making your data findable, accessible, interoperable, and reusable. And these are the basic principles that guide the Gen 3 architecture. Next slide. So I'm going to quickly go into Gen 3 features and a little bit about our products, but I'll just mention that after this, I'll be passing it off to Chris, who will show you a demo and it'll make a lot of this crystallize for you. But hopefully, I will sort of help you begin to develop the vocabulary of Gen 3 so it's a little bit more approachable. So the basic features are user authentication and authorization. This is basically who are you and what data do you have access to. This can be manually managed or synced with external sources of authorization, such as dbGaP used by NIH in the US. Uh, we store and manage multiple types of data. Each can be assigned, or each is assigned a persistent digital ID, sometimes known as a global unique ID or GUID. This includes structured data. This is basically data that you'd find in a database. Within Gen 3, it must align with the data dictionary that you specify. You use this to build cohorts and find files of interest. There's unstructured data. This is basically files in a bucket that can be downloaded for further analysis. It could be a genomic file, an image file, or a spreadsheet or something else. We also have a class of data that we frequently refer to as semi-structured. These are schemaless JSON blobs, but basically it's project metadata. So this helps you identify different projects of interest so you can learn more about them. It comes with a user interface for data management, exploration, and analysis. Uh, but of course, all of our services, including the data, are also available via API. It includes analysis workspaces that allow analysis of data without download by using popular tools such as R and Python. It is cloud agnostic. It can be deployed on any cloud, on-prem system, or local location. Next slide. It is, of course, open source. So the software is maintained by the Center for Translational Data Science at the University of Chicago, but with robust community input and contribution, such as from events like this. Um, it is microservices based, meaning there are many independent repos or services that together constitute Gen 3. You don't need all of them for your particular Gen 3 deployment. Deployment of services and containerized workflows are managed by Kubernetes, with Helm used for automating deployment. Observability tools are also included, meaning allows you to look into who's downloading data or how much data is being downloaded, etc. Uh, it supports secure data sharing. So CTDS, which is the Center for Translational Data Science, runs its systems at FedRAMP moderate, and so Gen 3 has regular patches to maintain this level of compliance. This isn't to say that everybody's installation would be automatically FedRAMP moderate, just to indicate to you that our system and because we are FedRAMP moderate, we have a very high standard for security, and so that is embedded in how the system is architected and the level of patching. Next slide. Okay, so quickly before I hand it over to Chris, I want to introduce just a few other bits of terminology that might help with his presentation. So our, I guess, primary product is Data Commons, which are platforms that co-locate data analysis, exploration, and visualization tools with data management services for import and export of structured information. So this is typically clinical information, phenotypic or biospecimen data, and data objects such as genomic data files or medical images, etc. This is just a couple screenshots of a data commons that I think Chris will go into much more detail on shortly. So data commons are capable of interoperating with other resources in a data mesh, which I'll explain on the next slide. Next slide, please. So a data mesh, sometimes known as a data ecosystem or data fabric, consists of two or more data commons, data repositories, knowledge bases, and applications over a common set of services. Basically, the data mesh doesn't hold the data, but it offers an ecosystem, I guess, of the different data commons. So you come to the data hub, which is the sort of single point of discovery, and you have access to find all of these other different nodes or data commons in that ecosystem. Uh, this is supported by what we sometimes refer to as mesh services. These are the Gen3 services that provide file indexing, associating metadata with data objects, and controlling user access. This graphic on the right is just indicating how different contributors can provide data to different mesh nodes, which can then be made available through the data hub. We're highlighting on the bottom a few important Gen3 data meshes. One is the HEAL data mesh. So this is making data available from the NIH HEAL project, which is helping to end addiction long term. There's the Biomedical Research Hub and the MIDRIC BDF Imaging Hub, which makes available access to lots of different imaging data. Next slide, please. Um, Finally, there are workspaces. So this is rather than downloading the data, this allows you to analyze the data in the cloud where the data are. This is secure data analysis environments that can bring together data in a mesh or from a data commons. By default, Gen3 workspaces include Jupyter notebooks in our studio, but can excuse me, but can be configured to host virtually any application. Workspaces utilize the Gen3 mesh services for user authentication and authorization, and for retrieving data objects and metadata. Here's just a few screenshots of different analyses that were performed on a data set in the Biomedical Research Hub. Next slide. Um, Before I pass it off to Chris, I just wanted to highlight all the different Gen3 data commons um, that are around. So this is available at stats.gen3.org. It highlights on the top the data meshes and data commons that are managed by our center, CTDS. And some stats from those. So this, is dozens of petabytes of data for millions of subjects and tens of millions of fair data objects. Most of these are, or many of them are open, so feel free to take a look around. The ones at the bottom are community provided Gen3 commons or data meshes. We have little to nothing to do with them, but we love to highlight them. If you're aware of others, please let us know. Next slide, please. So with that, I'm going to turn this off over to my colleague, Chris. Chris, take it away.
Thanks, Michael. Is it okay if I share mine? Okay, there. Oh, I turn my camera on there. Hi, guys. Okay, let's jump right in. I've got some slides to show you, and I'm going to try and move through those relatively quickly to get to the live demo portion towards the end of my slides. I'm just going to make some comments and then we'll dive into some details. So I, in preparing this presentation, I wanted to divide the different types of usages of Gen3 into four main categories, which are data management, that's like ingesting the structured and semi-structured data and file uploading and indexing, data or resource access. So tailoring your authentication and authorization, um, tailoring the Arborist UI, which is essentially Arborist is our policy engine that determines, who has access to what, including the UI pages. So you can allow certain users to view certain pages and others not. And of course, file downloads. How does that work? And then data search. So we'll go over some queries as well as the front end components. And then finally, data analysis. We'll talk about um, apps, integrating custom apps that are specific to your research use case. The resource browser, which is what it's called in Data Portal, which houses typically tutorials or other examples. Workspaces, which is our primary product aimed at data analysis, and then the soon to be productionalized. It's currently in test, which is the test, our task execution service. And I wanted to start this whole discussion of these different topics by pointing out that anything that you can do in the front end, which currently is either the front end framework, which is our um, newer front end app, or the older app, which a lot of our instances are still on, which is Data Portal, you can do over the open APIs. So one of the really great things, in my opinion, about Gen 3 versus some of the other systems one might use to share data are that all the Gen 3 APIs that do all the things in a data commons or a data hub or in a data mesh, those can be done programmatically by making API calls. The API, you can hit all the endpoints programmatically using your favorite programming language like Python, or if you wanted to build a React app or something like that over a data commons, assuming you have access to the data, you can do so. So it enables a ecosystem of apps and other analysis tools to emerge. Okay, so again, I'm just going to try and go through each one of these relatively quickly and then do some live demos. But just some general information about data management in Gen 3. I divided this into three uh, types of data, which Michael already went over, which is file objects. So generally in Gen 3, file objects are indexed in using the index-D service of Gen 3, which essentially mints a permanent digital ID for the file and links that to a cloud or wherever it's stored. Could be a local server as well, like Clever Safe or Ceph or something like that. And then there's structured data ingestion, structured in the sense that it is employing the data model. So it's tightly controlled, which I'll get into. It's enforcing harmonization of the data so that all the data sets that may come from different sources are harmonized or standardized to a specific vocabulary that you define in your data model. And then there's finally semi-structured, which Michael already touched on. That's flexible JSONs. And it can really contain any type of data that you want. It'll accept pretty much anything as long as it's a JSON. Um, and there's no links or hierarchy inherent to this. There's no controlled vocabulary like with the structured data with the data model. The types of data that are typically ingested in Gen 3 resources are things like publications or data sets, which Michael mentioned. There's also crosswalk data, so-called crosswalk data, which are privacy preserving record linkages. Let's say two different repositories, including yours, have data for a subject cohort. Well, you can use the metadata service, the semi-structured data, to link those subject IDs between the two environments so that users can convert from one to the other. And then things like package metadata. So for example, if you're storing zip files in index-D, you can create metadata records that list the zip file contents. Um, I have a little image here and a link to the Gen 3 Python SDK because I'm a big fan of using the SDK as opposed to the UI for a lot of this stuff. And I'll demo it. But but yeah, check out the SDK if you're into comfortable programming from the command line. It's a really great way to do all the things in Gen 3. Um, and I have some links in here. So just so you're aware, we have this doc site, docs.gen3.org. This is our detailed documentation. We also have gen3.org, which is kind of our higher level documentation. But docs.gen3.org is where you'll find all the nitty-gritty details that you more than you ever wanted to know about Gen 3. And if you find your way to the operator guide, um, and then look for data submission and search configuration. You'll find a lot of really great resources, including details about how data are submitted. And for hubs, we have, um, aggregate metadata adapters. So essentially what these are doing is they're hitting different environments and pulling their metadata. So you'll find things like clinical trials, API adapters that will sort of automatically um, pull in metadata to your data hub. These are discovery metadata, not files. So it's just hitting their APIs and pulling the discovery metadata. Um, okay, so that was data management. Data access. So just wanted to make a couple points to give you an overview before we jump into the demos. So one is that it uses an attribute-based access control policy engine. I already mentioned, it's named Arborist that controls user access to both data and compute resources, as well as UI components. And there on the right, you can see a little image that shows sort of how it works, just kind of an overview. You've got different types of users in your data commons, and you can craft different policies for them, and then assign those policies to those user groups that give them access to various compute and data resources. I have a link here to an example. Um, User YAML, or as we call them, YAML being yet another markup language. So nothing special there. This is just basically the user whitelist, just to show you, you can create anonymous policies that are automatically given to anyone, even if they haven't authenticated. There's all user policies. This is anyone who's authenticated gets these. They can view open data, they can view the query page and use it. And then there's things like admin groups who have all the access to do things, and you have data submitters who just have access to create and CRUD access, create, um, update, and delete access to structured data as well as files. And then there's developer, you can slice and dice however you'd like. And you define your policies, which have different roles and resource paths, and you define your roles as well as your resources. There's these resources which are like the query page in the portal. Can a user see it or not? Can a user use it or not? Workspaces, things like that. And then you have data resources. So these are sort of, you're defining which data sets a user or a user group can view. Um, Okay, so you can tailor, fine-grained access to compute and data resources. Um, there's also access in the sense of, reading the data, and that takes place in the Explorer and Discovery pages for structured and semi-structured data, respectively. And then files are accessed via their GUIDs, and you can, assuming you have authorization to download or access a file in a workspace, you can use either our SDK to do a DIRS pull, or you can use our Gen 3 client command line tool to both upload and download files. Um, I'll make this one pretty quick. So there's just all the different types of data, structured, semi-structured, and unstructured data. There's ways to query it. The structured data queries are using the Peregrine and Guppy services in Gen 3. Essentially, those hit two different databases. Peregrine's hitting Postgres, and Guppy is hitting Elasticsearch. Um, I could say a whole lot about this, but I'm going to kind of glaze over it here just to make sure we have time for demos. Semi-structured data. These you're essentially just again submitting and retrieving JSONs. And it supports aliases. That's kind of an interesting thing. So when you're using a crosswalk service, you can give it an alias for a subject in one data commons or another or a third, and it will return the record for all of them so that you can find subject IDs across repositories. And then unstructured data queries, we're talking about files again. You can query indexed. There is a field in indexed called metadata that you can use to power queries. So it's maybe hard to see on my screen, but there, in the example I've given, I've named the type of data, a DICOM header file, and you can search for that via the indexed service to find all of the files of that type. But it's completely flexible in terms of the metadata you can attach to file index records, so you can um, make it easy for yourself to find records you're interested in by assigning metadata keys and values. Okay, and then finally, Gen 3 data analysis. So there's quite a bit of different types of analysis in Gen 3. Um, and we'll get into these in the demos. So there's custom apps. These are like code that you've written. It's an application you've written, and you can integrate it into the Gen 3 Commons. There's the resource browser, which lets you provide tutorials mainly, but also I think you can include just about anything there, but generally contains things like example tutorial notebooks. And there's Workspaces. Workspaces are secure platforms for data analysis. Essentially, they're Jupyter Lab running in a VM of different flavors that you can tailor to your users' needs and load them with tools, notebooks, and other software that your researchers want to use. And finally, what I mentioned that we're currently testing out our task execution service. It's very exciting. And what this is, it's a way to run pipelines over data where it lives. So you don't have to pull data into another location like a workspace from where it lives. You can analyze it in place. You can essentially ship your pipeline to different nodes in a data mesh, and those nodes will return the results to you so that you can continue your analysis and not necessarily have to log in and download any data from any of the connected interoperating nodes in a mesh. Okay, so I think I'm doing okay on time. So just to give you a little preview, I'm just going to go over Gen 3 Data Commons, some features of Gen 3 Data Hubs, and then finally round us out with taking a look at Gen 3 Workspaces. Um, and I'm going to try and touch on each of these four topics, both from an operator and a researcher perspective. We'll see how well I do. But Michael had mentioned stats.gen3.org. I typically use this as a launching point for demos because it's a really great place if you're learning about Gen 3 and want to look at some examples to get a really good feel for all the different types of things you can do in Gen 3. Um, so right now we're thinking about data commons, and the first topic I was going to touch on was data management. So trying to go over how you import structured data, semi-structured data, and data files to a data commons. And I'm going to use my favorite data commons because I'm heavily involved with this one, which is MIDRC, the Medical Imaging and Data Resource Center. It is a data commons that um, was launched to address the COVID-19 pandemic, but has since moved on to ingest other types of data beyond just COVID, CTs and X-rays. We now have MRs and a growing collection of other types of CTs and X-rays and ultrasounds and all sorts of different images, as well as radiology reports. Anyways, very cool resource. We're talking about data management though. I chose Midric for another reason, which is that there's this production site, data.midric.org, which has this is all open access data. That's one reason I chose it, is because I can show you real data here without any worry about it being controlled access, but also because um, there's a couple interesting things about Midric. One is that since its aim is to facilitate machine learning in medical imaging, they have two data intake portals and they put 80% of that data into the open access commons and they run a sequestration algorithm. It's a stratified sampling algorithm that looks at different subject facets as well as imaging things like modality, and splits out 20% of those subjects to so-called sequester or keep in a restricted access data commons called validate.midric.org. And this one is closed off to all users except, someone who's trying to test an algorithm that they've developed on Midric data. And that's to make sure there's no bias. We don't want any of this data to leak out and, bias the testing or training of an ML model that used Midric data. So I think that's really cool. But the second reason I chose Midric is because Midric has a staging environment, and I did want to point that out as a great model for anyone who's planning a very public or large data repository, um, to essentially point out that workflow of what we do is we stage new data in Midric, in staging.midric.org. This is restricted access. You can't view any of the data without logging in. Um, and that's so that we can QC everything after we ingest it, make sure it looks good, make sure there's no errors with anything. And then what we do is we flip it over to the production side at data.midric.org, and they should match once the data release happens. So since staging is not a production environment, I can make changes to it and not worry about anyone getting mad or seeing something strange. Uh, so that's sort of the final reason I decided to use Midric staging for this demo. So yeah, I'll go ahead and get into it. So first thing we got to do to manage data in Midric is log in. And I am an administrator, so I'm going to have a lot of access. If I want to check what access I have, I can go to my profile here. And this is where I can also create API keys for interacting with Midric APIs programmatically. And I can view my access to various data and compute resources. So you can see I have access to all the pages and all the programs because I'm an administrator. But if you weren't, you would probably see a shorter list of things you have access to here. Um, so the main thing here is I'm going to use this project. It's a cancer imaging archive project called RICORD-1A. It's a COVID-19 CT, chest CT data set, which is open access and public. So no worries about seeing the data on a webinar. And you can see I have essentially administrator access. That's what the star means. I can do just about anything to that project. Um, so to if you, I'm going to show you first the UI for managing structured data, and then we'll go into. I'll just briefly show you how to do it from the API as well. Um, and I'm going to try and go quickly, but if you have any questions, feel free to reach out to me or look at the documentation. There's tons of examples. So I guess first and foremost, when you are submitting structured data, you do need to understand the structure of the data dictionary, which you can view with the dictionary button here. This is running the old front end data portal. There's also the front end framework will have Metric on pretty soon. It has a similar functionality where you can view all the different nodes in the data model and view their properties. So each node is going to have some required properties. The link to its parent is always required. It always requires a unique ID for all the records, and you have to tell it the type of data it is. In this case, it's a case or a subject. And then there's all these optional properties. And what we do, and each one of these has a different type and it has a description, and you can even link to third-party standards, which we highly recommend. So, if a user is like, I don't know how you came up with these categories for ethnicity, you can link out to a third-party ontology that very clearly defines what ethnicity is. So, yeah, so you need to understand the data dictionary because you've got to submit data that conforms to the data dictionary. One thing to make this easier for you from the dictionary page is if you look at the graph view, you can select, say, like, I want to submit some imaging studies. I can click that and view the properties. But what I can also do is click download templates, and I want TSV templates. And what that does is it downloads a folder that has all a template for each of the one of the nodes on up to project. So that's going to be imaging study, case, and data set. And you can see here they are. They're essentially just TSVs with the headers. There's a star on the ones that are required, and all the others are optionals, meaning you can include values or not, and your submission will go just fine. So that's the data model viewer or data dictionary viewer. Um, to actually submit data, you will go to the submission endpoint, assuming you have permission for this UI component. Typically, it's up here in the top bar of the data portal, submit or browse data. And then you find the project ID that you want to submit, and you click it, submit, browse data. And what's happening right now is on the back end, Peregrine is querying the graph to figure out how many of each type of node is in this project. And here is a graphical representation of the data that's currently in this project. If this was a brand new project, you would just see this very first node here, project one. But you can see it's a fully fledged project with a data set, record, 110 cases. They have medications and measurements, which are, I think, COVID tests. And then there's 120 imaging studies for those cases, and linked to those studies there are 229 CT series files. So I prepared just a quick and dirty demo. So what I did was downloaded um, where is it? I downloaded a case TSV, which oh, here it is. Okay. And you can see when I click that TSV and load it here in the UI, it populates all the data that's in that TSV. This is something you would create yourself. And then you click submit, and it submits in chunks. Basically, what that is just to prevent API timeouts. It takes, I think, 20 or 30 records from this list of records and submits them, 30 at a time. We can click the details. You can see in this case, it's not created in any entities because I'm actually running an update. So somewhere in here, let me just go to the bottom. It should say updated entity count 30. If these were new, it would say created entity count, and it gives you some information about each one. So nothing interesting here because we've just overwritten the case data with the same data. But I wanted to show you, what happens if there's an error, and some cool stuff. So I'm going to show you now how to do this programmatically. So I'm going to run IPython, which is essentially just a Python shell running in my terminal. And this first bit here, I'm just setting my home directory and importing the Gen3 SDK. You would have to, if this is your first time, you would have to install the Gen3. You can do pip install and it should work just fine. And then here, I'm going to initialize two different APIs. So I'm initializing an auth class that's going to handle my authentication, a submission class, which handles submission and query of Postgres data. The query class is handling Guppy queries, and then index class is handling indexd. And then this expansion class is a bunch of functions that I wrote that kind of expand upon these basic SDK functionality. So we'll just initialize those classes, and it's going to pull the project IDs just to confirm that uh, our SDK is working, and it is. You can see it's returning all the projects. So, okay, so now we're authenticated and we've got our SDK is set up to interact with Midrix staging. So, first thing I'll do is show you the submit file function. So this one is going to submit that same data set, the case data file that I uploaded in the UI, but it's doing it programmatically. And you can see it was successful. And if I want to look at all the details, API responses, I can. And it's just saying everything succeeded. We did it in one chunk. That's great. So what happens if you have an error? I did want to show that really quick. So I've got a TSV here that I manually made a couple mistakes in that TSV just to demonstrate that the API will respond with error messages that help you troubleshoot what the problem is. So you can see age at index. I tried to pass it maybe instead of yes or no. So this is property age at index is greater than 89. We're not allowed to collect ages greater than 89 for PHI reasons. And I said, you're supposed to say yes, the age is greater than 89, or no, it's not greater than 89. And I said maybe, and it's complaining about that, which is good. And then we've also set a limitation on agent index itself that it will not accept a value greater than 100. I've tried to give it 100, or sorry, greater than 89. I've given it a value of 100 and it complained about that and it didn't accept that. For sex, I tried to give it snail. It's saying that's not one of male, female, not reported, or none. And then for the link to data sets, I misspelled record here, and it's saying that's an invalid link. It didn't find a data set named record 1A. So yeah, that's structured data submission. Uh, if you wanted to export data as a user, let's say I wanted all of the TSVs in this project, you can click in the UI, you can click any of these nodes, and it will open up a viewer where you can view individual records as a JSON. And then, because I'm an administrator, I can actually delete them from here, which I'm not going to do. But a really handy functionality is you can download all as a TSV. And you can see you may not be able to see too well, but grayed out in my browser, there's a URL. It's hitting the submission API, that's Sheepdog, and it's giving it the program, the project, and it's saying export the case node as a TSV. And if I do that, we can just confirm that downloaded essentially that same TSV that we submitted a minute ago. If we made any changes here, they would be reflected here. You can also do that programmatically. I have a little function called get project TSVs, and you can give it a project ID, and it'll start downloading it. Um, oh, I mistyped the project ID there. And so basically what it's doing is it's looking through the data model, at all the different nodes in the data model. It's saying, oh, there's no MR, DX, MG, but for all the ones that do have records, it's downloading them. And if I look, um, there they are. Well, no, I think it told me where it downloaded them. Doo-doo-doo. Um, oh, project TSVs probably. Yeah, okay. And then yeah, so all of our TSVs I downloaded are there. So that's sort of from an end user perspective how you would access the structured data. Um, let's see. I also wanted to show so semi-structured. Here's just a quick, I'm not, I don't want to run out of time here. So I'm just going to go through this pretty quickly. but this is hitting the metadata service, which is our semi-structured database. And I'm asking for, I've given it an argument saying I want it to be a GUID type of discovery metadata, and it pulled it using this URL. You can see this is the MDS metadata endpoint, and I've given it an argument. I want, the first 1,000, and I want discovery metadata and actually include the values here. So if I look at that, it's a big dictionary of a bunch of different metadata records. Um, and this may make more sense here in a minute when I show you the discovery page. But essentially, this is a record for this data set, this TCIA record, CT, chest CTs of COVID positive patients. And it's got things like the object ID of files there, as well as, a data citation, the authors, the publication, the DOI link, and all that jazz. So if I wanted to make a change, I could, change I've got this one record for TCI record. Let's say I wanted to change the data contributor from RSNA to actually say Radiological Society of North America. I can make that change here and then post an update. And you can see that it's submitted to the metadata service. And um, yeah, we can check out that record by just going to the MDS endpoint here and finding data contributor. There it is, Radiological Society of North America. And I can just reverse that really quick by submitting RSNA again, come back to my browser and reload it. And it's back to what it was before. Um, just to tie all this together, like I'm talking about semi-structured data, I'm showing you JSONs, which is probably kind of a weird way to approach this. Um, just so you know, this is feeding this data sets or the discovery endpoint. So discovery takes records of GUID type discovery metadata, and it displays it here on the discovery page. So if I look up RICORD 1A, here it is. And this is actually reading, if I open the developer tools and I click it or run this search, it should uh, it's going to be, you'll see it hitting NDS here. Yeah, here it is. So there it is. It's just pulling in all those metadata records, and then the discovery app of the data portal is displaying them for you. And this does free text search, so you can do things like chest CT, and it pulls up the ones that are related to that. And it supports data downloads. So if your project has data files to download associated with it, you can um, link the GUIDs there so that if a user clicks it, um, they can download the file itself, which is pretty nice. So that's sort of the discovery page. Um, okay, let's see. Let's get back to where these levels that I'm where I'm here. Okay, so we looked at Midrick, we looked at, oh, I was going to show you file upload. That's right. Okay, so this is we'll get back to meshes here in a second. But I just wanted to show really quickly how that works. So, oops, I'm not going to do this in IPython. I'm going to go to my shell here in a test directory, and I'm just going to configure the command line tool. So what I've done is I've given it a profile name, I've given it the API endpoint of Midrick staging, and I pointed it to my credentials for Midrick staging, which I downloaded from the Midrick um, profile. So I created this a few minutes ago and saved it to my computer. But just to show you how that works, you click create API key from your profile, download as a JSON, give it a name, and then you've got your API key. That is a secret, so do not share the actual contents of that with anyone. It's essentially going to let them impersonate you in the data commons if you do. Um, you can look at your authorization. This is the same thing I saw in my profile, right? It's just telling me what I can do for the different projects. And then what I'm going to do now, just to show you how it works, is I've got these test files. They're test.txt files. And what I'm going to do is run a command called Gen3 client upload. I'm giving it my profile. So that's going to, so it knows what API I'm trying to hit and it has my credentials. And I'm giving it an upload path of star.txt. And what that's going to do is upload everything in this path that matches that wildcard expression. So it should upload all three of these. And so you can see it's found them, gives me a little message that it found these and it starts uploading them. And you can see at the end, it says we succeeded with three files. And for each one, you can see it uploaded them to a GUID. So now if I go to Midric staging and I go to the index D endpoint, index, and type in that GUID, you can see there's my test.txt file. So there's now a file, it's in Midric's bucket. So that actually uploaded it to S3 and it's calculated the MD5 sum hash, given it a file name, but you can see there's no authorization or ACL. There's no authorization. So no one can actually pull this file yet using the GUID. What I have to do now is go to back to that submission endpoint. And there's another little function here uh, on the submission page, which should load here in a second. So as it's loading each one of these projects, it's actually running, what is this, like 100 Peregrine queries to tell me how many of each thing are in each project. I'm just going to manually go there. So files, if you go to submission files, it opens up this file mapping UI. There's also a button at the submission page, but it wasn't coming up fast enough, and we got to move on. So I just wanted to show you this file mapping. What this will do is it'll create structured data for these files I've uploaded, and you essentially will just choose a project. You choose a node in that project. We'll just say supplementary file. And then for the required properties, each thing you're trying to map is going to get the same value here. So if they take different values, you can't, select them all. You've got to do them in batches. But we'll just say, test file, test, and then test, and then we'll click submit. Um, and it's giving me an error. But that's essentially how you would do it. I'm going to actually delete these. If you use the deletion functionality here at the submission page, it should delete them from your bucket as well. Okay, so that was file upload. Um, cool. Okay, so now I was going to talk about data search. And I think it's probably best to start on a on the exploration page. So I'll show you the exploration page of Biodata Catalyst just to change it up. So we were on Midric. I want to show you a different environment here. This one's kind of locked down, so I'm going to have to log in here. And there's a couple things here for data access of structured data. So one is the exploration app, and the other is the discovery page, which we just looked at in Midric. We looked at those data sets with the MDS records that were displayed there. I don't actually know what. Okay, so yeah, BDC also has data sets here as well that you can do a similar thing. Just look at the metadata. There's also study filters. So you can tag the different studies uh, with arbitrary tags and have them be displayed here. So let's say, I want dbGaP studies. I can just click that tab, click that tag, or, use these filters to do it. Let's say I want BioLink studies. It'll do that fast filtering for you. and you can read all the metadata, um, as well as, if there's data files, you can access them here. So that's the discovery page. Then there's the exploration page. So while discovery is hitting the MDS endpoint, exploration is going to be hitting Guppy. So it's hitting Elasticsearch. And I could talk ad nauseum about how you set all this up, but I'll leave some of that to Alex here in a bit. He'll talk a little bit more about how this stuff's wired together. But exploration is sort of the bread and butter of most of our Gen 3 data commons. It's where you come to do what's called cohort building or cohort selection. We also call it faceted search because you're using facets of the data with these checkboxes and sliders as well as search boxes to select a cohort. Um, and you can configure different tabs. Data here, I think this is looking at subjects. Files here, obviously, we're looking at different types of files. And then you can select, let's say, you want to look at VCF files. So you look for, what do they call them here? Um, like simple nucleotide variation, for example. Um, and then you can, export them to an analysis workspace like Terra. You can download them, create a manifest, export them to another place, Seven Bridges, whatever you want to do with those. But what this is doing is unlike Discovery, which is looking at like whole data sets, whole publications, you know, or whatever, it's very flexible. You can look at whatever. Exploration is looking across projects. So you can see here's project IDs. It's looking at all these different projects. And I've selected, simple germline variation files, and it's found, you know, 8,000 in this one, 8,000 in that one, and so on and so forth. So this is, if you wanted to build a what you would call, I guess, a virtual or synthetic cohort of subjects across all these projects, based on some different facets, you can do that here. Like, let's say you want males who are Hispanic or Latino, who have um, some sub cohort or some smoking status, whatever your particular data commons, you know the type of data you have. You do some selections and it filters it down. And again, this is across projects, so you can see, like, go back to the project tab and see how many subjects are coming from each different project. And that's pretty similar across all of our data commons. Midric has a very imaging focused Explorer. So this is Midric's Explorer. And you can see there's a lot more different views of the data here. So this is cases or subjects. And you can select subjects based on when they started a medication, what type of medication, what type of procedure they had, were they intubated, stuff like that. What other comorbidities or conditions they have, whether they have radiology reports, demographics, different imaging related factors. And then, so these are different views. These are viewing a specific Elasticsearch index. This one is cases. You can also view the imaging studies index, radiology reports, data files index, and slice and dice the data however you'd like. All right, I feel like I'm running short on time, so I'm going to try and move a little quickly. But I do want to show you, let's see. I do want to show you some analysis apps. So just to show you, some custom apps really quickly. I'm not going to go into too much detail here because of time, but there's this functionality where you can, in Gen 3, where you can um, create your own apps. You can run notebooks. You can see I didn't even log in, and I can run a little exploratory analysis notebook there. There's also things like BAM viewers. Really, whatever type of app that you can build, you can integrate it into Gen 3 for your users. That was K9. Just to show you a different one here. This is the Veterans Precision Oncology Data Commons, or VPODC. It's got VA data, which is very locked down, so I'm not going to actually show you anything here. But there's a GWAS app, patient level prediction models, as well as a OMOP CDM browser where you can look at view the data and here via the OMOP data model or Odyssey. Um, so very cool. There's also the resource browser. I'll just really quickly show you. So that would be, here's the resource browser endpoint, and you can see here in Midric, we've got a big collection of tutorial Jupyter notebooks. You can click them and, view the code. You can provide links to things like Midric's GitHub repo, where you can run all the notebooks. Um, and you can even open some of these notebooks in Colab to do things. This is a notebook that is, let's see if my credentials are still here. No. Okay, so it's not going to like this. But anyways, just to show, I'm not going to actually, since for time reasons, not going to run through this notebook, but just to show you like sending how queries work over the API, you can define various filters the same way we made selections in the Data Explorer. You can say, Hispanic or Latino males. You can say, I want people over the age of 70. I want X-rays, CR and DX modalities. I want chest images. Um, I want, you know, people that had an image done, within 2 days of a COVID test that came back positive. And then you give it an elastic search index here. I want imaging studies, and you apply your filters, and then you run it, and it will, essentially return back that TSV that we downloaded, but it'll be filtered for, the filters that we applied. So very cool. Way to do things programmatically in Gen 3. I'm going to save workspaces for the next part. How am I doing on time? Michael, do I need to wrap this up now? I don't want to take up all of Alex's time.
I guess fairly soon if you can.
Yeah,
Um,
okay. All right. Well, okay, I'm going to skip showing you meta API adapters for hubs, but just to touch on data management, um, well, I actually already showed that. So yeah, you can write adapters that hit APIs to aggregate metadata across a data mesh and data for data hubs or data meshes. Um, Less typical, you can run Sheepdog and run an ETL and use the Explorer for that. Most of our hubs use the discovery page, so it's using the MDS service. But you can use Sheepdog and Guppy for that, and Tube and all that you do for the Explorer. Um, Data search. So again, the two main pages you're going to do searches with are the discovery page and the Explorer page. There's also the query page that I didn't show, but it essentially is a query builder. Um, I can actually show you guys. Sorry. I can show you that really quickly in Midric since I've got it open. Let's see if I have anything in history. No. Okay. Well, put me on the spot. I'll just show a quick query. You can run queries from this query page, and you can see I started typing. If you start typing A, it gives you all the options. So it's pretty handy dandy for learning, how to do things. Let's say I want to look at imaging studies. For these cases, I can just start typing and it'll autocomplete for me. So, and I do want to point out if anyone wants to look at the schema, you can click that docs button here and then it'll show you all the different things and operators you can use. So it's very, very handy for learning how to build queries. That's if you're programmatically minded like myself. Um, okay. And access and hubs, so typically hubs don't host data files themselves, but rather the hub will point users via a combination of persistent IDs, URLs, or other types of pointers to data. Um, to the host platform where they can access it. Um, and there's also the task execution service that we're going to have out soon, and I'm sure there'll be another forum on that where you can run pipelines. You basically are sending out your analysis pipeline to the different nodes in the hub and getting results back. So very cool in the sense that you don't have to do the legwork to log in and download and yada yada, learn these different platforms, but rather you can just do it all from the hub. Um, and then, of course, workspaces can pull data on users' behalf. So, yeah, I did want to show you really quickly these two examples. So the Explorer page and the Discovery page for meshes or a hub. So this first one is Midric's imaging hub. And what it's doing is it's actually displaying data across the imaging data fabric. So there's Midric, there's 189,000 imaging studies from Midric here. There's also the Stanford platform, the Imaging Data Commons platform, NIH Clinical Trials platform, the Cancer Imaging Archive platform, American College of Radiology DART platform, and Open Neuro. Um, and you can slice and dice the data by imaging study, by subjects, series, and even data set level. So it's this is using the Explorer again. So the data were ingested into Sheepdog and ETL'd via tube to Guppy. And so this is all running off of Guppy queries of Elasticsearch that was created the standard sort of way. Um, However, most hubs use the aggregate metadata service and the discovery functionality. So if we go to healdata.org, this is a opioid addiction helping end addiction long term is what it stands for, and it's focused on the opioid crisis. You can again, this is discovery, so this is running off of the metadata service. And you can see there's over 1,000 studies here. You can do free text search. You can search via tags. So here, what I'm going to do is I'm going to choose a couple of them. Um, I'm going to choose NIDA, and I'm just going to show a free text search. So I'll just search for narcotic. I can spell, and that's pulling up the farm scream study. Um, and what I can do to kind of show you the discovery page and workspaces all in one, and then I'll be totally done and hand it off to you, Alex. I know I'm way over, so I apologize for that. Um, so I'm going to log in, which is necessary for using workspaces. I'll wait for this to load again. And then I'm going to click this button. You can see I have access to this data. I can read all about it, etc. What I'm going to do is check this checkbox and say open in workspace. And when I click that, it takes me to the workspace endpoint. And in Gen3, you can have a pay model. Workspaces is using a pay model. Luckily, as a developer, I get some free spending here. You can configure your workspaces with different flavors of workspace images. You can see as in terms of compute resources, these are all identical, but they're pretty small. It's just one CPU and 2 gigs of memory, which is not very powerful. You can make them extremely powerful if you want. You can allow certain users to use extra large instances and load them with whatever tools you want. But these are mostly data exploration. Um, Workspaces, so they're relatively underpowered. They're just kind of running some basic Jupyter Lab notebooks that hit APIs and pull in structured data or maybe some smaller data files. So you'll get this little uh, timeline here that tells you where you are in the process of launching the workspace. While that's launching, I'm just gonna take a look at this slide. So yeah, so essentially, each one of these flavors is a Docker. You can load it with software tools. You can load it with Jupyter notebooks so that users have all those notebooks and tools at their fingertips. You can again give it different compute and data resources. Uh, and users will choose a workspace flavor, which is what I just did. You can turn on a pay model. You can also offer non-paid workspaces where users just, you pay for it. Um, if you want, and you can even do both. You can offer sort of lightweight images that are free and heavier weight images that users pay for. Um, and then yeah, the typically these are running a Python kernel. You can see there in Heal, you can also run a Stata kernel or an R kernel as well. Um, and then you have a persistent drive that's mounted and unmounted every time you launch or terminate your workspace. That is your personal persistent drive, which where you can save all your stuff. You can see here's mine. And there's some demos I did 4 years ago. Uh, but if we go back to again, this is the tutorial notebook one. So if I look here, here's that farm screen study, and here's a nice Jupyter notebook that was prepared by our data scientist Jay Maxwell. And it does things like uses the dirst pull SDK command to pull a data file. Also, you'll recall that I had, and you can see that it downloaded, and I believe we should see showing up. I think this was a zip file. Yeah, there it is. Um, so, anyways, I'm not going to actually go into all the details here, but just to kind of demonstrate that we did actually download some data and you can analyze it here in the workspace. Um, if I wanted to save anything, like if I made changes to this demo and I wanted to save it, I would want to save it in this persistent drive. There's also, you can export um, when we clicked export to workspace, what that did was it exported a manifest and you can see they're time stamped. So 2 minutes ago, it exported this one. And
Chris,
yeah,
sorry to interrupt. Are you about done with
yeah, I'm totally done. Yep. Okay. So now, thanks for listening. Sorry, I went a little bit over, but yeah, now I'm going to pass it off to Alex Vantel, who is one of our senior software engineers, and he will talk about how to wire all this stuff together.
Yeah, thanks, Chris. Hey, folks. I'm Alex. I'm a senior software architect here, and I'm going to step through I guess I should say, step back a little bit and look at how all of these pieces connect. So, we just saw how there's a lot of different ways that you can use Gen 3. There's a lot of different services and features, and the way that we have architected the system is basically like a bunch of Legos, pieces that you can connect together to kind of do the sort of things that Chris was showing. And what I want to walk through is basically kind of some broad snapshots of like the main pieces of Gen 3 that compose together to form the features that you just saw. So we're going to start a little high level. I'm going to just walk through kind of the different pieces that you saw and how they connect, and then touch a little bit on the technologies that are going on behind the scenes. So one of the ways that we conceptualize software systems is by kind of breaking it into what's usually called like the front end or user interfaces, and what's called the back end, which is where you've got the databases, the data itself that's being persisted. And then you've got this interesting layer in between, which is like a communication protocol. So how does the front end talk to the back end? How does a command line interface or someone who wants to write against the back end logic interact with that? And that's where these application programming interfaces come in. So the way that we think about the architecture is we tend to kind of organize it in a way that is UI components, so user interface components. These are typically web applications. So everything that you've seen, that Chris was showing is through a website. So we have a front end that exposes the functionality that we want to users through those UI components on the front in a website, and then those are interacting like Chris mentioned with APIs, and the APIs are doing kind of the heavy lifting logic. And hopefully, I won't offend any front end people. The front end does a lot of heavy lifting too, but a lot of the data persistence and a lot of the logic that's going on, the querying is the front end, asking through the API, the back end, and there's a number of services that are powering that capability. So Michael mentioned at the beginning that this is a microservice architecture, and you'll see as we go through that there's a handful of different services, and I'm not even going to cover all of them or show all of them in the slides because there's more than even what you need to do kind of the basic functionality that we've seen today. The cool thing about all of this is that, like I said, like this is kind of like Legos, so it's very flexible. If you want to use, if you want certain features on and certain features off, you can do that. If you want whole like swaths of Gen 3 to not be enabled, you want to build your own custom piece for something, you can do that. If you want your own front end and you don't want to use the front end that we have available, the APIs are documented, completely open, the back end, everything is open source, so you can build your own front end on top of that. This is all very flexible. The other thing that I'll note is that we do update things on a regular basis, and I'll touch on security very briefly at the end. But if you're going to adopt the open source, we recommend that you try to stay up to date with those monthly releases to pull in all of the bug fixes and security patches and whatnot. So one of the ways that I find useful to think about the way that we've architected the system is to think about how people interact with it. So from a user perspective, and as you've seen, in the demonstrations, there's actually some different personas. So users could be the consumers of the data. They could be researchers, at least in a lot of the cases of the Gen 3 instances that we have, but they can also be the producers of data, the maybe the operators of that Gen 3 commons or Gen 3 instance that want to provide data into the system to make available more broadly to other people. And those are, the authorization is very flexible, as Chris demonstrated. The researchers tend to be read access. They want to see the data, and the operators tend to have write access. So they're the ones actually doing all of the submission that Chris was showing, submitting the files, submitting the structured data, and we've organized the kind of user journey to kind of clump these things together. So when from the researcher perspective or someone who's coming into Gen 3, which is, you can kind of think of it as a data platform. It's all about the data that's in the system. And so the main first thing that people want to do is discover what's available. They want to know, maybe before they even have access to the data, let's say the data is controlled access, they want to know how much data is available. Like, is there enough for me to do or answer a research question that I may have? The next thing that they're going to do is then filter the data down to a particular subset. So they then want to be able to search on the potentially controlled access variables, or only obtain some parts of the data to then build a subset of the data that they want to do some kind of analysis on. That subset, a cohort, they want to potentially save and manage that. So we need to know who the user is. We need to attach some information about the user and save that cohort of theirs. And then you want to send that cohort to do some kind of analysis. So into those workspaces, into those Jupyter notebooks that Chris mentioned. So that's kind of the journey through the system. Next slide, please. So the way that we can walk through the different parts of the system based on that journey is kind of looking at the interface on the left here in the blue boxes and what APIs that interface is talking to and what services power that API. And that kind of walks through the system all the way from the user's perspective in the front end, all the way to the back end. And I'm not going to go over necessarily every box in the next few slides, but I want to highlight some of the stuff that you've seen to kind of connect the dots as to what is powering what you've seen so far. So what I'll mention first is that there are some services like the Rev Proxy, which operate within the back end, and they don't necessarily have a front end component. In this case, this is basically our traffic director. So every request that comes into the system goes through this reverse proxy service, and it gets routed to the appropriate backend service depending on where the request is coming in. So not necessarily part of discovery, but part of all of the services on the back end. So one of the main UI pages that you saw was the discovery page. And if I had $1 for every time one of us said flexible or configurable, I'd have a lot of money from this meeting. But I'm going to say it again, the discovery page is very flexible. So you saw a bunch of different examples of how you can show different types of data, whether it be study metadata or imaging metadata, and you can show that in a way that allows people to discover what data is available by using these semi-structured blobs of information. And the front end can be configured to display certain columns, to display certain ways of filtering the data, to have a free text search box. All of that is highly, highly configurable, as is the Gen3 landing page itself. So, as Chris was clicking through different instances of Gen3, there's different colors, there's different logos. All of that is very customizable. From the backend perspective, what is actually powering that discovery page is this metadata service. And we mentioned this earlier. There's kind of two different APIs here. There's a metadata API, which we also call the semi-structured data API, and then there's this aggregate metadata API. So depending on which flavor of Gen3 you are wanting to have, if you want a mesh versus a kind of a data commons instance, you are either providing the data from your own instance or you're aggregating it from different sources. And so there's slightly different APIs for that. But behind the scenes, it is the metadata service that is powering that. I will mention this AI stuff very, very briefly. So a couple of forums ago, we talked about our roadmap, and we mentioned that we're working on some sort of foundational AI support, which I'm not going to touch on today because that's not quite ready, but I just wanted to highlight that there is a lot of stuff going on in this space, and we would be remiss not to mention that there is up and coming support for Gen3 that will provide some foundational AI support. There is, however, some AI services that are available today that we built, a little over a year ago. So if you're interested in looking at those, one of them is the Discovery AI. I don't think it's in any of the commons that were displayed, but the idea was, you've got that free text search box. Could you have some kind of similarity search that helps people find data of interest? So that's one of the available services as well. Next slide, please. Okay, this is where we get into the nitty-gritty details that Chris was avoiding talking about, which is the structured data. So one of the biggest benefits of using Gen3 is that a lot of the API and a lot of the data management is sort of like automatically generated once you define a data model. So the data model itself is a configuration into the deployment of Gen3, and once you configure that data model, you actually get an API for submission and validation of data and querying of that data based on that configuration automatically generated. These data models, we come from, mostly biomedical data, but there's nothing restricting the data model from being locked down to the biomedical space. In fact, it is entirely flexible. So once you define a data model being, the kind of tables or nodes with different properties and the relationships to other nodes or tables, then you get this structured data API, and this is the kind of submission API that validates the data coming in to make sure that it aligns with the data model. So the error, when Chris was showing like the errors that you get, that's validating the incoming data against the data model that's been defined and letting you know when it does not match the required types or naming conventions. Sheepdog is the service behind the scenes that is handling the structured graph submission. So it's doing the validation, and it's also storing the data in a Postgres database. We have a custom wrapper on top of Postgres, which is an open source database solution that is able to do kind of graph-like representation of data. Peregrine is the service that exposes a GraphQL interface over that Sheepdog database. And that GraphQL interface is what Chris was showing, where you can kind of type in just what you want to receive back. So you can just say, give me all the patients, I only want their age, and it will only return that information to you. So it's sort of like a data saving query language. GraphQL is an open source query language that we've adopted. In a lot of places, we try not to reinvent the wheel. So if there is a community standard or if there is a well-accepted internet standard for how to do something, we try to adopt that. So in this case, we've adopted GraphQL for the searching over the data. The ETL is where things get a little bit interesting. So all of the data that you ingest, depending on how complex your data model is, and depending on what kind of queries you want to do in the front end, querying over that Postgres sheepdog database can get sort of intensive as your data grows and depending on how complex your queries are. So you likely, or you may, or you likely will need to cache a subset of the data that you want to make searchable in a persistence layer that is optimized for kind of dynamic searching. And Elasticsearch is the technology that we chose for that. So we have a service that helps and a job that helps with moving data from the kind of source of truth sheepdog database into this data cache. So it extracts the data from the Postgres database, it transforms it. Usually that's some kind of denormalization or flattening process. So you may not want to search over every single field that you ingest. You may just want some of the fields. So you kind of transform the data and then you load it into Elasticsearch. And on top of Elasticsearch sits Guppy, which exposes the same GraphQL interface, but over the Elasticsearch data. And Guppy is actually what the exploration page is built on. So all of those facets where you're clicking different things and typing in different filters, that is interacting through Guppy over the cache to get you that really fast faceted search. Okay, I will also note, I think we are going to intentionally blow past 5 o'clock. So if you need to drop, that's fine. This will be recorded, but I'm going to probably go 10 minutes after going through the rest of the slides. So just a note to folks. Okay, let me cover a little bit more about the UI here. So the exploration page you saw, that's kind of our main page where you are doing cohort building. You're subsetting the data based on the data model and the ETL of the data. Whatever you want to make searchable, you can expose through this exploration page, and you can, subset to some set of data that is of interest to you. You can also write GraphQL in an interface. So Chris was also showing that. But again, all these APIs are accessible from the command line or from your own code that you can write. So you can do this without going through these UIs if you so choose. The data model viewer is the page that we saw that showed the kind of graph-like representation, also the table view that is powered by the configured data dictionary, which is exposed through the sheepdog service and through this API. And then we also saw some UIs for data submission. So Chris walked through all of that. One other component here is there are some jobs on the back end that bridge the GraphQL queries into some import and export capabilities. So there's another technology that I think we have some forums on. If not, there's documentation certainly in our on docs.gen3.org about PFB, which is a portable format for biomedical data. This is a serialization format, and in cases where you build a cohort and you hand that off to an external system, there are some tools for taking your GraphQL query and creating a kind of ephemeral file that is very, very space efficient, that can be transferred over the internet very efficiently, and you can move that into analysis or workspaces, either Gen3s or we interoperate with other systems as well. Okay, next slide, please. So we've walked through the user journey. We've discovered data in the discovery page. We've gotten potentially requested access if it's controlled access. We've gone to the structured data. We've, the operator has defined a model and submitted data. The researcher or the consumer of the data, the person coming to Gen3 and using it, has gone to the exploration page. They've filtered down data of interest, and now they've created a cohort that they maybe want to save to come back to later, that they're going to use for some kind of research question or do some kind of analysis. In order to do that, we have to know who the user is. So there's a lot of foundational services. We sometimes call these framework services. These are also heavily used in the mesh context. So they're sometimes called mesh services, depending on where your perspective and where they're used. But these are foundational services that are used for user identification and authorization, so authentication and authorization. So Michael mentioned this at the beginning. The services that power this are Fence, which handles the login process and some of the data access, and Arborist, which was also mentioned, which is the policy engine. So this is what's determining whether or not you as a user are allowed to, see a page, access a particular set of data, etc. From the front end perspective, the way that you get a view into this is that profile page, which Chris also showed. You can download API keys there. You can see what authorization you have. When you go through the login flow, you'll get pop-up pages about consenting to sharing your information if you're logging in through a third-party identity. And again, Fence is very flexible. Gen3 is very flexible in how you want to provide your login. We, like I mentioned earlier, tend to adopt internet standards if they exist. And in this case, this is a very well-established space. The OAuth 2 or OpenID Connect are standards and specifications that are in place for this kind of identity sharing that's in use, everywhere across the internet, and that is what we've adopted for these services. So we never deal directly with any passwords in Gen3. We rely on an external identity provider being the source of truth. So whether that be the NIH researcher auth service, RAS, or a Microsoft login or a university login, Fence is able to connect to those, giving proper credentials, and then log in users. And through that user YAML process, or through dynamic requests to access data through our requester service, you then get access to do things in the system. And Arborist persists that information as policies. And then as anything is happening in the system, that gets checked against Arborist. So that's kind of the user part of this management. And then from the researcher side, the kind of more interesting piece connecting to the data is saving those cohorts of interest. So one of the newer services that we have that isn't in place everywhere yet, but you can utilize right now, it's in production, it's been productionalized, is this user data library. And the idea here is a persisted cohort management. So it's a library of user data. You as the user can persist those cohorts of interest, those subsets that you've created from exploration can be persisted in this library in lists, and you can go to those and then you can export them to some analysis space of interest. Next slide, please. And that moves us to the final piece, which is the actual compute, the analysis. So you want to write some code, or you want to run some workflows, and over the cohort that you've created, or maybe over some other data. And the workspace page is kind of the established way of launching different notebooks right now. So you saw an example of that where we can launch Jupyter notebooks. So this is interactive writing of code and execution of code where the user themselves is interacting directly and telling it when to stop and when to go. We are in the process of adding support for workflows through a workflow execution engine, which is a sort of like run in the background type of support. So if you know that you want to run some kind of data processing pipeline, or you want to deal with a huge amount of files and you want to apply the same algorithm or the same tool over all of the files, you can write a workflow that takes input, runs some kind of code, gets output, and you can hit go and let that run in the background. We are building that workflow execution and task execution support with another standard, which comes out of the Global Alliance for Genomics and Health, GA4GH. Their task execution service, or TESS, is the API and that we've adopted, and we're using another open source tool from someone who another group that we're working really closely with to build the kind of support for executing tasks using the TESS API within a running Gen3 instance. Okay, a couple of other things that I want to note is, like I said before, and like I think Chris said before too, the API is accessible without the front end. So one of the really cool things here, like Chris was saying, is you can write code, you can interact directly with all of the querying and data ingestion that Gen3 provides without a user interface if you so choose. If you want to use the user interface or provide that to your own users, then that's available as well. The front-end framework is the modern kind of cutting edge, more flexible front end that we have released within the last year. So if you're looking to adopt Gen 3, the front end framework is the one to go with. But there are still we're still working on porting some of our older comments from the existing data portal into that front end framework. Okay, next slide, please. Okay, I'm gonna really quickly go through some of the technologies here. So everything is open source. It's Apache 2 licensed. It's all in GitHub. So GitHub has repositories, Git repositories, which is a version tracking technology, code tracking technology, and it's all hosted, so you can find links to all of this from our documentation for all the services and all of the code related to everything that we've talked about, that powers everything that you've seen today. I've already mentioned that this is a microservice architecture, so as you've seen, there's a number of different services that all work together, and one of the benefits of architecting in this way is that you can scale these services individually. So if you have a lot of data ingestion happening, you can scale the data ingestion services so that there's a lot of them and they can handle that traffic. If you've got a lot of people making queries, you can scale those services. Most of our code is written in Python. The backend services tend to be Python-based web applications that expose, where possible, standards-based APIs, RESTful APIs. We do have some Golang code in the mix. All of our services are Dockerized, and we build images that you can then orchestrate with using Kubernetes. Next slide, please, and I will talk a little bit about Kubernetes. So Kubernetes is an environment that allows you to basically run containerized services, which is how Gen 3 has been architected. Helm is a way that you can, it's a package manager, and we have packaged Gen 3, all of the services into Helm charts, which make it really, really easy for you to get started with all of this. So you don't have to set up each service individually. You can just install the Helm chart. There's some reasonable defaults. It gives you all of the configuration that you need to be able to modify things and, turn on and off features, turn on and off services that you would like. And that is exposed through the Helm charts. If you want to operate in Amazon Web Services like we typically do, we also have Terraform modules, which is kind of like an infrastructure bootstrapping technology. So you can run these and it will set up stuff in AWS to get that Kubernetes environment for you. But you can also run in other clouds. We are cloud agnostic. Okay, next slide. I already mentioned Helm, but just to kind of gloss over this again. So this is what allows you to define how to deploy and install and configure Gen 3. And there's a ton of documentation on our website, docs.gen3.org, that go over how to set up Gen 3 for the first time. You can even set it up locally if you have a little bit of RAM to spare to run all of the services. Then you can run this locally, try it out. And this is the easiest way to do so, and then make changes as needed to productionalize and configure on and off what you'd like. Okay, next slide. Okay, I'm going to touch briefly on security and then I will be done. So this was mentioned before. I just want to mention this again, that we have a couple of instances of Gen 3 that we operate at a pretty high security and compliance framework that is US government based, called FedRAMP Moderate. What this means in practice is that there's a lot of security first culture here. There's also a lot of processes that happen, like we have annual security and compliance audits that third parties do on our software, on our boundary. There are penetration tests where red team, security folks come in and try to hack in and see what they can do, and we make adjustments based on that. And all of that means that, when we build new features, we are considering security and privacy as part of the design process. Like security personnel and folks on our side are involved from the very beginning and the conception of new features, all the way through the deployment and the operation and scanning and vetting software. We are constantly patching vulnerabilities. All that being said, we can't guarantee any sort of security and compliance framework, because depends on your institution, your country, the type of data you're dealing with. But we can show that depending on how you do things, Gen3 is capable of being held under these kind of rigorous security and compliance frameworks like FedRAMP. Okay, I think that's it. I will pass it back to you, Michael.
Thanks, Alex, and also thanks, Chris, for all of the content you provided. I think, as promised at the beginning, we covered a lot of topics, none of them in a huge amount of detail, but I think it'll be a great resource for the users to go back to dive deeper into any of these topics they're interested in. So I'm just going to wrap up the meeting quickly here. Next slide. So how do you contribute to Gen3? So there's a variety of ways, principally through contributing to the source code. Um, we have some links here for instructions on how to do that onto the source code, but also through your involvement with the Gen3 community. So please join us on Gen3 Slack if you're not already there, and participate in these events. You can contribute to the documentation. We've had a couple links throughout on the documentation, but it's set up in such a way that you can easily make modifications and make your own pull requests to make updates to the documentation. Please also submit feature requests or bug reports as GitHub issues or in the Slack channel. So next slide. So I just want to wrap up with a few links that I think are helpful. So please take a look at any of these to find more information on any of these topics. And if you don't find an answer, please reach out to our email or on Slack. And then this last link, I'm just going to highlight the blog series. Next slide. We have recently started creating a few blog posts on our site, and these cover a deep dive into some of the topics shown here. So you can also take a look here if you don't find information on the particular areas of the documentation. So thanks. I'm afraid we don't have any time for questions today, but thanks so much to the speakers and all of the people that have participated or are listening in today. Yeah, please reach out if you have any questions. Take care, everybody. Thank you.